Hey everyone, I want to share with you a data inspection notebook for semantic segmentation datasets. If you are working in a semantic segmentation task or instance segmentation, this might help you. Imagine you have a dataset with a lot of images and you don't know if these images are noisy or if they're cleaned. So I developed a notebook where you can go through all your dataset very quickly and pick the images that you don't want, for example. And then you're going to save these images in a text file, the name of the image in a text file, and then later you can just filter the whole dataset. So I want to quickly share with you how can you do this. So first of all, if you check with me here, you have all the images and the ground truths, and in each image you can also see some masks that are added upon each image. So for example, I'm working with food semantic segmentation, and then I can quickly check which images are good. And this is especially good for you if you are using data-centric approach to solve your AI task. So for example, here I have good data. Here I don't know if I want this because I have some ice cream here. So maybe I pick this image. So I don't want this in my final data set anymore. And if we continue, we can quickly check that we have other images that are very bad. For example, this one is bad. This one is, the segmentation is very bad, so you can also pick it. And you can go through a whole data set very quickly. If you want to stay with me until the end of the video, I'm going to show you the whole notebook, how I developed it. And you can also check the GitHub, so you can also modify the code for a specific data set, and let me know in the comments if you like it. If you like it, please give a star in the GitHub repository. And if you're going to continue with me, let's go through the whole notebook. And this notebook is part of a data-centric framework specific for semantic segmentation and instance segmentation tasks. So besides inspect data notebook, we also have some other tools like ground truth generation using some computer vision techniques. I'm going to do other videos later explaining how they work. And I have some utility notebooks also that convert, for example, COCO datasets into another format, for example, ground truth format, as we see here, that is just for semantic segmentation. Maybe that is something that you need in your project. And I'm going to do other videos about that later. But let's go through the notebook here. So first of all, let me show you where my dataset is stored in my machine. So I have the ground truth images in the GT folder. So for example, here apple pies, we can see the GTs, so the ground truths, they are under this folder. And we also have the DOM folder. This is where I have the original images. So everything is under the two folders. So we have two main folders before starting the notebook. And here in the beginning, you have to specify where this folder in your machine. And we are using Fastai and also some PyTorch functionalities to create and inspect the data. So first of all, let's run some imports here. Let's import Fastai and some other tools. Here you're going to specify the path of your data. So here food 201 is my data set, and I also specify where are my images. So in the DOM folder, and also the annotations which are the ground truths. I specify here. You also need to create a function that is going to search for the ground truth given a specific image path. So you need to, for example, given the name of the image, you need to search for this image in the ground truth folder, in the GT folder. So you need to specify this. You can take a look carefully later if you want to understand better how it works. But yeah, that's something you probably need to modify in your project. Here, I'm just going through all the data and checking how many images I have in my data set. So 12,000 images. And I also need to load the classes number file. What is this classes number file? Let me show you. So if I come here and I check classes number, these are the classes names. So for example, if I have 200, and so in this example, I have 201 classes. So void is the background of my semantic segmentation task, and the other names, these are the class names, the full names, and we have 202 in total. 202 in total because I added also the background. So this is important to inspect the data. So we need to know what are the class names. Okay, let's go back here. And then we also create a color map that's just for visualization, just for the ground truth visualization. So if I have 201 classes, I create randomly 201 colors. And here you can also check for noisy data automatically. So let's say, for example, you want to skip images that has very small objects. So here there is a function that is looking for that and also looking for bad annotations automatically. For example, if you have two masks that has a high intersection, I skip it. That's something you can also process. So you can, instead of looking for these patterns yourself, you can also check for these automatically. So there's a function for that. You can also set if you want to use it. Let me show you in a minute how it works. And he's just a function, okay? He's just a function. I'm not processing anything here. Here is also other function definitions for data visualization. So this is what is going to create the grid with images and showing the original image and the ground truth below it. So this is just a code. So if you want to take a look how it works, you can check later in the repository. And here here's the part of data iteration. So if you want, for example, to iterate your whole data set, you have to specify here in the configuration. Just for demonstration purposes, I'm going to iterate 100 images in my data set, and I also have to specify here some configuration, like if I want to check or not noisy annotation. So I want to put false here. I don't want to check noisy annotation. And when I say noisy annotation is what I said, looking for small segmentation masks or masks that has a high intersection. And here is a flag which is controlling if you want to return the original mask. I recommend always setting this to true. And here there are some classes to ignore if you want to ignore some classes. For example, in my dataset, I didn't like images that has chocolate sauce and powdered sugar, so I skipped them. And here is the execution itself of this grid. So let's execute it again. Maybe let's just put 20 images so it's faster. So let's execute this. So it might take some minutes if you are loading, let's say 1,000, 2,000 images. Normally it takes for me 2 to 3 minutes. So, but that's okay to wait, right? And here we have a message saying we didn't ignore any samples. These ignored samples, these are in respective to the noise images. So since we set to false, we don't want to filter any noise image. We don't have any ignored sample. Okay, and then here you have the code executed, and you can just start picking the images you don't like or you do like. It's your choice. Here it's just a tool, so you can select images. If your purpose, if you want this just for select the good images, then you process this later. Or if you just want to select the bad images, then you process this in another way. So let's say, for example, I'm selecting the bad images. I don't want this one here. This one is terrible. And this one, I didn't like it also because here on the top, I think it's another food. So maybe let's skip this one. Okay, that's fine to just for demonstration. Or here, for example, it's also bad, you see? Okay, so after you finalize picking all the images, you just run this to check how many picked samples you have. So I just picked 4 samples, and here is the name of the images. And if you want to store this in a text file, you just run this in Excel. And if you also had executed the grid, so the data inspection, searching for noise data, you can also store this noise data here in the ignored image file. But since I don't have anything, this file is going to be empty. And if you come here again in your Explorer, your Files Explorer, you can check the 2 files are here. And you can check the picked images, and you can see here the 4 images are here. And later you can just post-process. Before training your model, you can just filter the files that has these names. And yeah, that's it. That's the tool I wanted to share with you that is helping you inspecting data. And that's really important for data-centric approach. If you are looking to clean your data set and you're working with semantic segmentation and instance segmentation, that's something you can use. It's open source, and yeah, that's really helping me in my project, and I hope it helps you as well. See you in the next video. Thanks.